So for this assignment, we must find the distance from Earth to Proxima Centauri in Wolf 359. In order to do so, I've drawn a model representing the problem using the measurements provided. In particular, L is the length between Earth and New Horizons, measured in light years. R is the variable that we need to find, the distance between Earth and the star. 54.8 is the given azimuth to the New Horizon, and B is the given azimuth to the star. B minus 54.8 is the angle between the New Horizon and the star as seen from Earth. F is equal to 180 minus, in parentheses, B minus 54.8 is the supplementary angle. The value of F in this case is less than 90 degrees. In this diagram, the variable D is how much the angle to the star changes when we switch to the New Horizon point of view. We extended the line from Earth to New Horizon, labeled Z to create a perpendicular line from the star to that line, labeled Y. To begin solving this problem, we first found the variable D by measuring the distances between different positions of the star in the animated GIF, which, in the case of Proxima Centauri, is D is equal to 1 divided by 20 times 1 divided by 1900 times 360. Now that we have this right angle triangle, we can say that tangent of F is equal to Y divided by Z, because Y is the opposite and Z is the adjacent. From here, we can change this equation into Y is equal to Z times tangent of F by multiplying both sides by Z. Simultaneously, we can also say that tangent of F minus D is equal to Y divided by, in parentheses, L plus Z. This equation can be changed to, in parentheses, L plus Z times tangent of F minus D is equal to Y. Since we previously already found that Y is equal to Z times tangent of F, we can substitute Y in that equation with Z times tangent of F, creating the equation L times tangent of F minus D plus Z times tangent of F minus D, and that this is equal to Z times tangent of F. To find Z from this equation, we must change it to L times tangent of F minus D divided by, in parentheses, tangent of F minus tangent of F minus D. We can also make the claim that cosine of F is equal to is equal to z divided by r, because z is the adjacent and r is the hypotenuse of the triangle created here. By multiplying both sides by r and dividing both sides by cosine of f, we'll get the equation r is equal to z divided by cosine of f. Since we know what z is equal to, we can make our final equation of r equals L times tangent of f minus d divided by, in parentheses, cosine of f times, in parentheses, tangent of f minus tangent of f minus d. We can use this equation to solve for the distance to both Proxima Centauri and Wolf 359. To use the formula we just made to calculate the distance to Proxima Centauri, we start with the knowledge that b is equal to 146.6. We also measured that d is equal to 1/20th times 1/1900th times 360. L is given to us at the start and it doesn't change. We also know that f is equal to 180 minus, in parentheses, b minus 54.8 and this is equal to 88.2. If we plug these variables into the formula we made earlier, we will receive our final result for the distance to Proxima Centauri, which is r is equal to 4.4822 light years to Proxima Centauri. We can do the same for Wolf 359. For Wolf 359, b is equal to 154.2. d is equal to 0.55 times 1/20th times 1/1900th times 360. L stays the same and f changes as a result of b changing, so f becomes 80.6. If we input these numbers into the formula we made, we'll get the distance to Wolf 359, which will be r is equal to 8.0441 light years to Wolf 359. Thank you for listening.